Welcome, everyone, to First Principles Podcast. We are your hosts. I am Trees.
And I'm Elliot.
Thank you for joining us today. Today will be a continuation of an episode that we covered recently, which focused on wind and solar energy and its integration into the Ontario electrical grid, or into the Canadian electrical grid more specifically. Now, today's episode is going to focus on continuing off that premise of, integrating solar and wind into the electrical grid and making sure that it's balanced with the idea of energy storage, which we touched on briefly last time, but we'll go into more detail during this episode, because you cannot have a discussion of wind and solar without integrating energy storage. And I think people are becoming more and more cognizant of this fact, and it's becoming talked about more and more. Obviously, it's been spoken of in the engineering field for a while now, but of course, those are the technical aspects of things, and it takes time for those ideas to then trickle down to everyday parlance or everyday speech, so to speak. And now I think is the time to actually look at, what does this mean when you have battery or whatever form of storage you have to compensate or to as an ancillary technology that complements your wind and solar. So we're going to be looking at a case study that tries to assess how Ontario could incorporate wind and solar into its electrical grid, but not only wind and solar, mixed with energy storage, mixed with hydroelectricity, and in comparison to nuclear as well. Before we jump into that, do you have anything to comment on, Elliot?
Sure. Yeah. Maybe it's, a bit cliche at this point or repetitive, but the idea is, what are we going to do when the wind is not blowing and the sun is not shining? Both solar and wind are considered unreliable energy sources for this reason. And we discussed this on the last podcast. How do you make wind and solar unreliables more reliable? And energy storage is that next step. It allows you to capture, the electrical energy that you can gain when the sun is shining and the wind is blowing, hold on to it, and then distribute it when it is no longer that case, when it is needed in the middle of the night, whenever it's needed, that power is needed. So yeah, let's take a look at what's going on in Ontario.
Yeah, and just to go off that a little bit, just want to say, if anybody's talking to you about solar and wind without the mention of battery storage that needs to go alongside of it to complement it, then they're not giving you a true full picture. I mean, even with that, it's still not the full picture, but it's not a wholesome approach. So hopefully we want to try to do a little bit of that today.
Yeah, and I would even say, if they're only even discussing battery, which we'll get into later in this podcast, they're not being completely honest about the other potential energy storage systems that are out there. Exactly.
Many different types of energy storage. So without further ado, let's jump into this specific article that I pulled up, and it was published on January 5th, 2020. And it is from the website called The Conversation. It's titled, "Ontario Can Phase Out Nuclear and Avoid Increased Carbon Emissions." Written by MV... You like that already, right?
Okay. This is interesting. Okay.
All right. Getting out to a good start already. It's written by MV Ramana, who is a Simons Chair in Disarmament, Global and Human Security at the Liu Institute for Global Issues, University of British Columbia. So based out of BC. I looked up this dude. I think he has like a PhD in physics from Boston or something, and kind of like he's now like an economist, policy type of writer type of dude.
Wow.
And co-author is his MITAC's Global Link research intern, University of BC, Xiao Wei. Apologies if I'm mispronouncing your name, Miss Xiao Wei. But it's kind of said like Huawei. I just thought of that, but
yeah.
Side tangent.
Well, that's a weird word. So with an H, right?
Huawei.
Xiao Wei.
Yeah. It's cool. I like it. Xiao Wei. Yeah. Anyways, side point. So let's get into this article. So I'm going to read you this article, and bit by bit, let's try to dissect it. Let's try to analyze it. I'll take pauses here and there, ask for your opinion, ask for your feedback, give my 2 cents, give my point of view, and we'll really analyze this piece of work. And that's one of the goals of this podcast, is how to take theoretical research, or how to take abstract work that others have done that's in the research realm, and try to break it down into its first principles and try to understand it in simple forms. Because whenever you have something complex, first step is to always break it down into its simpler components. So we're going to try to do that with this article. So it starts off by saying, as wind and solar energy have become cheaper, they've become a more prominent and important way to generate clean electricity in most parts of the world. The Ontario government, on the other hand, is cancelling renewable energy projects at a reported cost of at least $230 million, while reinforcing the province's reliance on nuclear power via expensive reactor refurbishment plans. As researchers who have examined the economics of electricity generation in Ontario and elsewhere, we argue that this decision is wasteful and ill-advised, and the unnecessary cost differential will rise further in the future. One concern about renewables has been the intermittency of the energy sources, but studies have shown it's feasible to have an all renewable electricity grid. So that's how the research report, I guess, or this paper starts off. Mm-hmm. And we'll try to, I'll link this to everybody else so you can read this for yourself as well. On the conversation.
And may I add, can you just, when you are reading, just slow it down a little bit, because I have never heard it before. I caught it, but just
sorry. Am I reading too fast?
A little bit for me, just to follow.
Maybe I should have sent you this article as well.
It's all good. I got it.
Okay, my bad. I'll try to slow it down. Sorry, I'm just like.
I know you've already read it, so yeah.
Get it. So these feasibility studies, however, are always location specific, which is important, right? We want to focus on a specific location. There's no silver bullet, magic potion solution for any one particular place. In that spirit, we have carried out detailed modeling and found that it's possible to meet Ontario's electricity demands throughout the year with just a combination of renewables, including hydropower and storing electricity in batteries. So essentially their claim is that they've done what they say are extensive and detailed models, and they, from these models, have discerned that they're able to meet the Ontario power demand with just renewable energy, solar, wind, hydroelectric, and battery storage. And then they did an alternative where they looked at throwing in nuclear as well to compare the two.
Okay.
Essentially. So let's look at modeling. To explore the relative economics of nuclear and renewable energy. Okay, so let me just, again, before I get too much into the details of this. So essentially they're making the case that it's cheaper for Ontario to have a grid that is tied to renewable energy sources such as wind, solar, hydroelectric, and batteries than it is to have nuclear energy within the grid. That's kind of like the main thesis that they are going to try to prove.
Interesting.
And they've essentially developed models, and we all love our models. We all learned everybody's favorite word of 2020 was model. What's your model? So yeah, let's go into their model a little bit.
Can I add one thing here?
For sure.
So it's an interesting premise, and it actually is brought up, I think, twice in some clips I found. This idea that electrical power generation through wind and solar is cheaper, and for that reason, we should pursue it. I'll let you get into this. I have more to say on it, but it is definitely, you'll hear it creeping up, this idea, people saying this, and I think we need to check exactly where it's true and when it's not true. But I definitely have heard it before.
For sure. And because it might be true in some cases, might not be true in other cases. Just because it sounds good doesn't mean it's necessarily true. So let's go into the modeling. To explore the relative economics of nuclear and renewable energy, we constructed a very simple model that optimized the total cost of meeting the electricity demand in Ontario for each hour of the year. we used what's known in physics as a toy model. It's not intended to be sufficiently accurate to reproduce reality in detail, but to capture the basic and important elements of the system being studied. Our model is not meant to actually calculate the cost of supplying electricity, but only to compare the relative costs of different options with the condition that no fossil fuels be used. So what they're saying is essentially that they acknowledge that they have a shitty model. It's very rough. It's very like rough calculations, but I guess it's just kind of trying to test out ideas. So they're admitting that they didn't do a whole lot of work. So it's very detailed. So I think that's actually one thing that I just picked up on right now. They mentioned that they did in their introduction a rigorous study, but then later they mentioned that it's a toy model. So that's actually one thing, again, I just picked up now, because earlier on they say that we examined the economics of electricity generation, Ontario and elsewhere.
Yeah, two things there. Mm-hmm. So I think we talked about this in our last podcast, but we said, one thing that models do is they let you know what's in the realm of possibility. So in their defense, I go, yeah, I agree. It's, ridiculous to say rigorous and then try to, pull it back a little bit from the edge. But there is a place for models to give you a ballpark of realm of possibility. The other thing, though, I thought was interesting. Did they say they completely eliminated fossil fuels from the calculation?
Yes. So these models have no fossil fuels incorporated.
And these models are looking at the economics of it, are they not?
They try to phrase it in this backwards kind of way, but yeah, they're essentially comparing the costs of what a grid that had nuclear incorporated in it versus a grid that didn't have nuclear and was primarily based on renewables, and compare those costs. Okay.
I mean, yeah, that is what it is, but that obviously is a problem, because they've put a world like an idea forward that simply has eliminated the use of fossil fuels altogether, which, okay. Yeah.
So, sure. I mean, so it's a model. Again, whether it's realistic or not, we'll get into that. So using a software program called PIPSA based off of Python, we started with an example, as important, that modeled a fully renewable electricity system for European countries and then modified it significantly. Our target was Ontario's hourly electricity demand in 2017, taken from the province's independent electricity systems operator, known as the IESO. So essentially what they did was they took pre-existing models that looked at a bunch of European countries and broke down how those European countries could meet their electrical demand with a renewable interplay of different, let's say, power generation and electrical storage components, and they tried to essentially rejigger those numbers to equal what Ontario could reasonably see. If that makes sense.
Makes sense. Great use of the word rejiggers.
Yeah. That's a good one. Yeah, you don't hear that one very often. I got those in the back pocket. Don't you worry. I got a few of those. So we met this demand in two ways: batteries and refurbished nuclear plants. Both cases incorporated solar energy, wind energy, and hydropower from existing dams. The base costs of solar and wind were taken from a November 2018 report by the Wall Street advisory firm Lazard. The prices have since declined. So they took costs from American numbers and tried to incorporate them into Canadian numbers. Essentially, like, we have base cost of solar and wind, right? So what's the cost of solar and wind? They took some numbers from Wall Street advisory firm Lazard. So it's, again, to say that it's very coarse. It's a very coarse analysis. There's not very much detail. And say, for simplicity, we assume that the variable costs of all these and I don't know if there's any issues with that stand out to you that you'd want to mention right there.
No, I mean, are they saying we've taken costs, and since this model has come out, the costs have gone down, which is in favor of the model? So it's saying, like,
favor of the model, yeah.
Yeah. So Yeah, that's
Okay, yeah, we'll continue. No worries. So for simplicity, we assume the variable cost of all these technologies were zero. This actually favors the nuclear scenario because it ignores the cost of uranium fuel and radioactive waste disposal. Any issues with that?
Oh, I didn't understand that. How did it eliminate the cost for disposal? What?
Essentially, it's saying that to simplify their study, they didn't look at costs, like how much it costs to mine the thing out of the ground.
Okay, that's a huge problem.
Yeah.
The cost for this is exactly, I think, what we're going to discover is the problem with people using the phrase solar and wind are more affordable, is they've just basically chopped off a bunch of costs that normally you would have to look at to be realistic about it, and have said it's cheaper. So red flag right there.
Mm-hmm. And we'll go into that in more detail, but yeah, I'll just point out some red flags here and there as we go into it. Red flags will be pointed out, believe you me. Okay. The availability factors for every hour of the year for the theoretical solar wind generators were also based on data from IESO on actual production of solar and wind energy in Ontario 2017. So it's saying that in terms of the availability of wind and solar, they took 1 year's of data and applied that into their model. One issue with this that I'll quickly point out that kind of applies to some of the other things that they did is that when you're modeling something, you typically don't want to take just 1 year's of data and put that into your model. Typically, you want to have a robust model, which means incorporating many, many, many years of data, tens, decades, if not hundreds, if available. Whatever's available, you put into your model, because the more data you have, the more certainty with which you can make your predictions. So if they're taking just 1 year of data, which they did on numerous occasions throughout this model, that is not a very robust or well studied scenario, because year to year there can be severe variations. There can be, like, you could be missing out on trends. You could be missing out on so much detail when you take out that temporal aspect of it, right?
Definitely.
Okay, so just a quick comment on that, and let's keep on moving. The maximum power available from large hydropower dams during any hour of the year was assumed to be less than 85% of the installed capacity within Ontario. This is a conservative assumption, since the province could easily import more hydropower from neighboring Quebec. Now, when somebody says could easily import more hydropower from neighboring Quebec, like, I feel like you're kind of underestimating how simple it is to take power from different municipalities. We do it, but know that we do it with substantial amounts of waste. It's not as easy as, hey, let's just call up Quebec. We need some more power. You call up the Quebec guys, and they're like, hey, qu'est-ce qui se passe? What's up, guys? Like, what do you guys need? And we just tell them, hey, just turn up some of that electricity this way. Like, no problem. Right, coming your way.
Beam it to us, Scotty. Beam us.
Yeah. Yeah, beam it down to die Ontarians. I'm sorry. It's just one of those oversimplifications where, okay, granted, you're doing it for the simplicity of your model, but it's just, it's you're taking away so much information that it's just, I don't know. It takes away from the validity of what you're trying to do.
Of your findings. Honestly, the amount that they've cut off, you know what I mean? Like that they've excluded from the model in order to create it, and they're specifying what this stuff is up front, reminds me of something we would do in like first or second year of our school, where we just didn't have the time to do it. It was obviously like this would be hugely important, but we're just trying to prove to our professors, for the course sake, you know, we understand the concepts of it. And
this is like first year shit. Yeah, that's it. Yeah, that's it. That's exactly what it is. This is like first year shit, and you're a prof with a PhD from Boston University or whatever the hell you got it from, and you're representing University of British Columbia. Like, I don't know, man. It's highly suspect. But let's continue. The maximum power available from large hydro power dams, which I read this before, but let's just reiterate because I have an important point for this. From large hydropower dams during any hour of the year was assumed to be less than 85% of the installed capacity of Ontario, which is about 9,000 megawatts. This is conservative, assuming that we can import electricity from Quebec. Now, why are we not using historical data on what was actually used? I mean, is it correct to assume that you'll be able to access 85% of the capacity at any given point in time? Because what they did previously was use historical data, but now they're using not historical data and they're trying to use quote unquote true data based on the capacity. But is that really an honest look at things? Because how are you going to get 85% of the diversion of the electricity at any given point in time when, this is a very important point here, there's approximately 3,000 dams in Ontario that are not supplying hydroelectricity but are serving alternative purposes such as flood control, navigation, water management. So when you have all these things at play here, you're not only looking at electricity, you're looking at how are we going to do with the flood controls? How are we going to do with water course? Maybe you have a channel or a canal and you need the water there at a certain level because you're planning to have stocks of boats come in for shipments. So what, all of a sudden you're going to be like, oh, let me change these water levels so that I can get 85% of my total capacity?
Oh, I see what you're saying. Yeah. You're like,
there's things at play that are out. Go ahead.
Yeah. Maybe I'll try to summarize it. Mm-hmm. So you have water management needs when it comes to water courses that have dams.
Water resources engineering. Go ahead, sir.
Yeah, exactly that. So in the spring, all this freshet water comes, melting ice, snow raises water. There's got to be dam management to prevent flooding upstream and downstream. And something that happens in Ottawa in the last few years here is massive flooding that has impacted many houses that are close to the edges of the Ottawa River. And so, simply saying we have complete control of the water to perfectly service the needs of energy at all times is unrealistic because there's other not contradicting but contrasting demands,
diverging demands.
Yes, that we need to take into consideration.
They're mutually exclusive.
So it could be, well, it's foolish perhaps to say that we can guarantee you'll meet, what was it, 80% at all times.
85% of the total capacity.
Yeah, I got you.
So again, this is really okay, guys. This is like really getting into like the minutia, like the details of things. But like, I don't know, you really gotta think about these types of things when it comes to the logistical application of these theoretical models. There's oftentimes a disconnect that happens, and things that are theoretical in models don't translate into the real life necessarily. So that's just one of the points that this article kind of misses. So let's go into their essential results. It says, in all scenarios, the bulk of the demand was met by solar and wind power, with the lower fraction met by hydropower. Even in the scenarios with no batteries, less than 20% of the electricity demand was met by nuclear power. So essentially what they're saying is that they had two scenarios. One was with batteries, one was with nuclear, and they compared the two. And what they're saying is that they were able to meet all the demand, and it was cheaper than if they had done so with nuclear power. And second, it would be cheaper to reduce this even further because of safety and other operational reasons. It's a bad idea to change the outputs of nuclear plants quickly. Traditionally, reactor outputs have been held steady. But if, for argument's sake, we allow the outputs of nuclear reactors to go up and down as fast as needed by the grid, then our model predicts that nuclear power plants would be used even less. If nuclear power plants' outputs are held steady, they would supply more electricity, but the cost to consumers would also be higher. So any red flags with that statement?
So I'm not a specialist in nuclear power generation, but what jumps out at me is thinking you can build a nuclear reactor that has that degree of flexibility is what I would think is a problem here. That was the only thing that I caught, though. I don't know if that's true.
That's exactly it. Yeah, no, that's exactly it. Because the issue with this is that it's saying that you can just easily turn up your nuclear power plant up and down, however you need it.
There's just a knob, like a volume on your boombox. Just dial it up a bit, dial it down, good to go.
Exactly. And okay, let me just tell you how this might sound like whatever if you don't understand like what this guy is saying, but let me just tell you how like ridiculous what this dude just said is. Because he's saying, if for argument's sake, we allow for our inputs of nuclear reactors to go up and down as fast as needed by the grid. So you're going to alter your nuclear reactor outputs as fast as needed by the grid. As fast. Let me tell you why that's a fucking stupid idea. Nuclear power plants do not power up and down as needed. This is a dumb thing to even suggest. Powering up and down is more costly than operating a steady state. This is a universal truth. Steady state is always cheaper than transient, which is starting and stopping. Not only that, let me give you a quote from the International Atomic Energy Agency. Pretty reliable source when it comes to atomic energy, I would say. The International Atomic Energy Agency.
You think they would know a few things about nuclear? Yeah.
Maybe more than homeboy over here. So, direct quote, international experience from operating nuclear units is that frequent operation in load following or automatic frequency control models leads to poorer reliability of the nuclear plant, less efficient use of the nuclear fuel, increased maintenance requirements, and possibly shorter plant life. Because of this, the most preferred mode of operation of nuclear power plants is steady full load. Steady full load. So what are the full? Crank that shit to 100. Let's go. That's the recommendation, with load reductions only when required for shutdown for maintenance and refueling. The second preferred mode of operation is normally at steady load, but increasing or reducing load at a controlled rate on a limited number of occasions when required by grid conditions. So essentially it's saying keeping it at steady state is the second best option. So first best option is steady state, but at full capacity. Second best is at steady state, but you can go lower than full capacity, but it's better to go at full if you want to optimize. So we have the International Atomic Energy Agency directly contradicting what our professor genius PhD here is telling us.
And let me ask you, how long did it take you to find that quote?
That contradicted what this dude said?
Yeah.
Like a 30-second, like I pretty much just Googled, is it okay to, or like some variations of Google, like, is it okay to power up and down nuclear power plants? I mean, I already know that the answer intuitively is no, but obviously you want to find sources that showcase that as well. So I was trying to see what's up.
Yeah.
And I came across International Atomic Energy Agency within maybe a couple minutes. It was
Yeah. And, you know, when we went to school, one of our main profs, or at least for our introductory years and in our later years, worked in the nuclear business or in the business of nuclear energy in that industry. So we've heard some, real accounts of what this technology is capable of. And, this gentleman, I've forgotten his name, whoever did this paper, he's in a university. He must have contact with people that are knowledgeable in this area. So two things: either he's chosen not to acknowledge this fact out of just laziness to research it, or he knows of it and he just is going to supply some unreasonable assumption to make his point. So, I mean, what is it? And either of them are not great. So, yeah.
He's being lazy. He's being lazy or dishonest. And either or is not good.
Exactly.
You would expect higher from your quote-unquote intellectual superiors.
Now, there's not a sentence after that goes like, this is an unreasonable thing to request. It just basically says because he makes for argument's sake. Like even his language around it is strange. Like
all he says, he does allude to it. He says, because of safety and other operational reasons, it's a bad idea to change the outputs of nuclear plants quickly. Traditionally, reactor outputs have been held steady. So he does allude to that fact.
Okay.
So he knows better. Essentially, he's saying that he knows better. He knows what he's say. He knows what he's about to say is stupid, but then he says it anyways.
Yeah.
So I don't know. It's just very dishonest because I don't know. Like I read into this dude and he's into nuclear disarmament, and I guess that's his whole shtick. Less of nuclear, less nuclear. But if your whole game is nuclear disarmament, then we kind of know what your end goal is, right? Right.
We know your bias. We know your bias.
We know how you lean. We know you got that lean. So let's continue on this, though, with one of we're almost done here, close to the end. So finally, and perhaps most consequentially, if the cost of batteries declines from current levels of those projected for 2025, then cost of supplying electricity using a combination of renewables and battery storage would become cheaper than doing the same using nuclear power. The cost of meeting the electricity needs for the province could be further reduced if the availability of hydropower is increased. So they're also talking about, increasing hydropower there. But what I want to focus on is the idea that battery costs will decline, and this supports their argument. And I want to tie this back to a really important point of how this whole thing started, which was based off of a bunch of European models, right? So just to tie it back to the very beginning, this model took a bunch of European models that looked at 30 countries in Europe and tried to assess how those 30 countries could meet their electrical power demand with a variation of solar, wind, and battery storage. But what this guy doesn't mention anywhere within this article is that there's no mention of the fact that it's actually hydrogen storage, not batteries, but hydrogen storage is the predominant energy storage method that's used in these models that this guy is quoting, right? So there's no mention of hydrogen storage, only batteries are in the article that this guy writes for Ontario, which is an inaccurate depiction of what is being referred to in the European models, because your whole thing is that you took these European models and you just rejiggered it for Ontario, but yet you failed to mention that those models, they reference specifically using hydrogen electrolysis, which you don't mention at all within your paper.
Oh, this is super interesting.
You don't mention this because it would be inconvenient to mention that we would need to set up a whole new hydrogen infrastructure in Ontario. Gotcha, bitch, gotcha. Gotcha. It doesn't exist. So let me tell you how dishonest this is. The European models, they used 30 countries. 30 countries were using the European model. Out of the 30 countries in the European model, only 2 to 3 actually had more battery storage than hydrogen within their models. So the Ontario model is based on only a fraction of what the true model was trying to show. To me, I was just mind blown. I was like, how could you say that you took this model and you try to recreate it, but then meanwhile you took away 90% of the battery of the energy storage mechanism that it was proposing?
Wow.
I don't know. To me, it was just like, what are you doing here, man? Like, do you even know what you're talking about here? Literally, you all you got to do is look. They give you, within the article, they give you the link. Hey, we linked it to these electrical models from Europe. You look at them, and they all have a breakdown. How much of onshore wind, how much utility solar photovoltaic, how much battery storage, how much battery inverter, hydrogen storage, hydrogen electrolysis, hydrogen turbine. From Finland to Spain, Portugal, Norway, France, UK. The only ones are like Cyprus and like Macedonia.
So 2.
Yeah, and like the smallest countries, Cyprus, Macedonia, and maybe Slovenia is close too.
Yeah.
So which shows that we're dealing with those European models, a totally different system than what this guy is saying.
I think this actually goes deeper than him ignoring it for convenience sake. We'll get into this a bit later, but I don't know what's going on exactly, but there seems to be a suppression. This is speculation of hydrogen, and I don't know why, but I think there's something else going on more than just simply this guy chose to clearly ignore this for the sake of making his point when it comes to why we're not hearing more about hydrogen. But I'll get on into more of that later in the podcast episode here.
Mm-hmm. Mm-hmm. Yeah, and that's an interesting point. If there is a suppression of hydrogen going on, because I would almost agree with that, not to get into too much conspiratorial realms, but theoretically, hydrogen and electrolysis, the process has been known for over 120 years, 150, almost, if not 200 years almost, I want to say. So this is a known process, and it's sat on the back burner for a really long time, but I think that is slowly changing. And looking at these European models, which did incorporate hydrogen storage, to me it shows that the European countries maybe are a bit more open and serious about using hydrogen, whereas maybe in North America it's still kind of lagging behind.
Yeah, and let me clarify.
Right.
I meant it in terms of the hydrogen use in Canada and the US, because like you said, we see Europe has adopted hydrogen, and I believe there's a big push either in South Korea or Japan when it comes to using hydrogen fuel cells and this technology. So it isn't that I just think there's something more going on in Canada and the US specifically. What it is, I'm not too sure. Maybe nothing, but it's well, you'll see that it's a bit convenient in other cases where they've left out hydrogen. So why is this? And you know what? I think, well, you know, when we talk about hydrogen in a later podcast, we can definitely look into that, why that might be.
Yeah. We'll definitely have a podcast that's dedicated exclusively to hydrogen, because that's a super important topic that we need to give our utmost dedication and focus onto. I want to kind of go back to one of their results that they pointed out. One of their first results, actually the first result that they highlighted, was that in all scenarios, the bulk of the demand was met by solar and wind power, with the lower fraction met by hydropower. Even in scenarios with no batteries, less than 20% of electricity demand was met by nuclear. So I want to just break down this statement. So take out the nuclear scenario. So we only have the scenario where we have solar, wind, hydropower, and batteries, because again, this guy's not talking about storage with hydrogen or electrolysis or anything of that nature. It's strictly batteries. What batteries? Which ones? We don't know. Some theoretical batteries that exist out there. So what he's saying is that the entirety of Ontario's demand could be met by these renewables. Now, when we look at the current status of what the current capacity is, obviously just would not be feasible, because when we look at wind, that's 7%, and when we look at solar, that's 2%.
Of what? Sorry.
Of the Ontario current production.
Right.
Whereas with hydro, we're looking at 26%.
So is he saying completely get rid of hydro, because hydro is considered renewable? So
no, he's saying include hydrogen. Oh, sorry, or hydroelectric, I should say, okay. not hydro.
Right.
So his is just strictly hydroelectric. So I want you to picture this scenario. It's nighttime, so you take out solar, and say like it's not a very windy night, right? It's a quiet night, whatever. The wind ain't blowing for whatever reason. So take out wind.
Okay.
So based on this guy's model, what you're left with is hydro, right?
Unless you have energy storage.
And energy storage, exactly. Hydro and energy storage, exactly.
Yeah.
So he's saying that their model was able to meet Ontario's power demand with purely battery storage and hydroelectric power. Let me just say one thing. There's no current batteries that can power a large chunk, all of Ontario's power demand. Like, you can't set up a freaking set of batteries that are just going to power the whole province. Like that's literally almost what this guy's suggesting, to rely on batteries to power all of Ontario or like majority of Ontario, which is essentially what this guy's claiming, when it has never been done on such a scale, means using an unproven system, which is where we get back to this whole unreliable thing. We're pushing stuff further beyond what it is truly capable of based on the hype, but don't believe the hype. It's true for a reason. To suggest all power could be provided by battery tech when solar and wind are not operational is insane. Like, it's just fucking insane.
Yeah.
So you take solar and wind out of the equation, you have hydroelectric and battery, and they're saying, yeah, our model was still good. Get the fuck out of here. Like, what? Are you kidding me? Like, what are those, tell me, what do those battery power plants look like? How long does it take to create them? I don't know. Because they don't exist. They literally don't exist. So they're trying to build up all this hype on something that doesn't even exist.
Yep.
Like, what in the F? Think about it. Like, we have even if we got max hydroelectric, 26% of Ontario in 2018, 26% of our power was met by hydroelectric. So you're telling me 4% with batteries?
Now, what's even more crazy, if you expand this out, and we talked about this on our last podcast, a lot of places don't have the fortunate predicament that Canada has, where we can take a large part of our renewables from hydroelectric setups. A lot of places don't have the geology for it. So imagine, if it's unrealistic to think we can't meet 42% on energy storage, how the hell are you going to do that on a place that doesn't have hydro and try to do it? We even have the benefit of hydro working around the clock here, and it seems like a problem. Now, is there a peachy future where we develop the technology, the battery technology? Yeah, it's a possibility, but there are other forms of energy storage that need to be considered here. Now, we're going to talk a bit more about energy storage and the other types of energy storage that exist besides batteries that can be used to supplement this dilemma of batteries, basically battery technology not being at where it needs to be in order to maintain these long drawn out demands, but to not even acknowledge at this point the use of these other storage systems. Again, it's just not honest, and it's unimaginative. I don't want to go too far because we're going to talk about the other forms of energy storage soon, but simply put, this is just, one of the many types of problems so far I've seen with this case study or model that has been put together here.
Yes. And let's continue with some of the final points I have on that case study, and then we'll wrap up this case study. But one of the other points I want to allude to that this article brought up was that finally, and perhaps most consequentially, if the cost of batteries decline from current levels of those projected for 2025, then the cost of supplying electricity using a combination of renewables and battery storage will become cheaper than doing the same using nuclear power, right? So this is alluding back to that point where we have better technology, so it's going to be cheaper, Meanwhile, this totally neglects the fact that once you already have batteries established, then to rip them out and put a whole bunch of new, more efficient batteries, that's a whole nother expense. That's a whole nother issue that I'm not going to get into, which I just thought of and came to my mind as well as I'm reading this. But I mean, obviously, every 5 years is going to sub it out or something, but maybe you will because they're unreliable. But let me get to a more important point on that, which ties in the policy aspects of all this stuff, which we talked about before, where unfortunately, when it comes to incorporating renewables, solar, wind, oftentimes the failures might not be necessarily engineering failures, but policy failures as well. So I'm going to highlight something right here, which really contradicts that statement. So that is to say that this neglects to mention that in 2009, former Liberal Premier Dalton McGuinty announced a sweeping green energy strategy, including the feed-in tariff that would pay companies and individuals a premium for generating clean electricity. It was an economic development tool to encourage manufacturers to build wind turbines and solar panels here in Ontario. To create a market for such equipment, the government encouraged farmers and others in rural Ontario to install wind turbines and guarantee them fixed price over 20 years for the power they generate. That's why there's so many turbines and solar panels in the countryside. So even though technology gets cheaper and cheaper, sure, you still got to pay the same amount because for your electricity. So if you're trying to tell me that electricity is going to get cheaper over time, well, you know what? The government set up these contracts where they fix those prices, which means that those prices ain't going down, which is an example of how policy can really mess and muddy things up more than help them. Maybe this was done with good intentions, but for the people, what this ultimately means is more cost to your electricity. And when we say, oh, wait, but things are going to get cheaper, well, what difference does it make if you fix the cost for 20 years?
I mean, there's so many issues with that. I mean, just simply, isn't this not the same as price fixing? And,
yep,
you know, in an economic system, I can't even start to begin to go down that route of why that causes problems. And even if it's done for the, you know, in the name of trying to support renewables, which I support, the introduction of and use of, I just think it's not the right foot you want to start on. And as you pointed out, it will lead to more problems than it fixed potentially. So, you know, what are we trying to do here at the end of the day?
Yeah. And it really just shows how there's lots of simplifications that are used in models. When you're developing a model, one of the first things you do is state your assumptions. And this is a really important thing that I think we need to start asking more from our political policy leaders is, okay, great, you have this model, but what are your assumptions? What are the assumptions that you're using upon which you built this model? Because again, whenever you're building a model, first thing you need is boundary conditions, which are fundamentally your assumptions. What are the assumptions that are going to govern the reality? You're building a world. What are the assumptions that govern the world that you're building? And we need to be more diligent with understanding that there is this link. Models give us outputs based on the assumptions that are put into them. And we need to have this understanding and this connection that it's not enough to know your model, but tell me what the assumptions are that your model was built upon.
Yeah, I would say no politician understands these models or the assumption of the models. I think where you have to push back on this is at a stage where the political party is asked to develop a board of experts that they rely on. The experts tend to be scientists, engineers who develop models that give outcomes that shape policies. The pushback has to be, done by, again, educated people in the realms of science and engineering on those models. So it almost needs to be like, what are those called, where you basically have a debate. You go, this is my panel. They're making this argument we're going to shape the policy on. And then you set up another panel that's basically there to go through it with, a less biased perhaps or counter argument. But they are not your just media educated individual reporters. They it's hard for, I can't even imagine, hey, Justin Trudeau, I'm from CBC News. This would never happen. But what were the these model assumptions seem off to me. He's going to be like, what are you talking about?
I mean, they should be asked those questions. Why not?
They should be.
I feel like you should, yeah.
Well,
or at least have the right people be like, okay, I'm going to bring up my specialist, my model expert, and then they're going to answer it, which sometimes they do as well. But those politicians should understand at least like a Cole's Notes summary form of it, right?
In an ideal world, yes.
Yeah.
Yeah.
Which maybe they don't, because like you hear about all these freaking omnibus packages that are passed where it's like 5,000 pages of legislation and you have literally 30 minutes to read it over and vote on it. Like what the, like you're not going to read 5,000 pages in 30 minutes or like in 2 hours, 3 hours, whatever the hell they have. It's ridiculous to expect somebody to do that, which again kind of alludes to like the issues with policymakers and how a lot of policy and legislation is passed nowadays.
So I heard that narrative more recently come up in the U.S. Around that omnibus bill there, and I heard a counter argument that actually says there is laws built to give you more than the time period that some were arguing they had and that it was almost up to 72 hours to review a new policy. And the other thing to keep in mind that the policy basically for months there's section of these that could have been reviewed. So theoretically, large chunks of this policy people actually had the time to review. It was the slight changes to the policy that they needed to review in the shorter time period. I'm just pushing against this because I've heard this idea and I was like, oh, that seems really unfair to have like all that material you have to cover in a short period of time. But it is, I think, funny. Like that's why I think what got slipped in there was you have to declassify everything we know about aliens in the U.S. or the government has. That was just kind of slipped in there. But yeah. No, I know it's.
I mean, even if they did have 2 months, that's still an insufficient amount of time, and I don't think that negates anything of what I said, because okay, you have 5,000 pages. Sure, you had 2 months to review it, but now we're giving you a draft of that 5,000 pages. So go ahead. So now you still got to review it based off of your previous knowledge. So you still gotta like compare your notes. Okay, what was my first issue? Let me check that section. Did they make the change? Like, it's not. It doesn't negate the issue in that regard, and also doesn't negate the issue in the regard that you shouldn't have one omnibus package that covers like 10,000 different issues all in one. Right? That's still an issue in itself, where each individual policy should have its own separate vote. You shouldn't be having all these things, all these separate issues that aren't even attached to each other on a certain level, and they're all just jumped together. And it's like, okay, I like this one, but I don't like all these 10. But I guess if I want the one, I better vote for it. Because if I don't, then people will say and focus on that one and be like, oh, you don't care about X. But, well, no, I care about X, but it was Y and Z that I wasn't voting for.
Yep.
You feel me?
Oh yeah, I feel like that is the primary purpose of Omnibus now. Like people can say, and I said this before, counter arguments may be that we need these large bills because looking at each one is too time consuming. You got to kind of vote on them all together. But like, no, that doesn't even make sense. Like it seems to me omnibus bills are used to make a certain people have to pass stuff that they don't like in order to pass other things they do like, and it's just like a way of slipping stuff in and kind of playing the negotiation game when it comes to passing legislation or passing these bills. I mean, so it's like it really, I do not agree with the concept of an omnibus bill when it comes to how it's used in politics. It's just
it's a greasy negotiation tactic for sure.
Yeah.
It's a greasy way to compromise.
That's it. Yeah.
But I want to allude to, so that kind of like brings us to the end of that article. So many red flags that we talked about there, and kind of following along that same idea of looking at nuclear and the push that has been coming against it. It's really being demonized. A Green New Deal, they don't care about nuclear. All the new kids on the block, they don't really care about nuclear. There's actually some interesting graphics that I found from the Washington Post, which essentially highlights each of the candidates when it came to the U.S. presidential election and what their stance was when it came to nuclear power plants. And let me tell you, it doesn't have a lot of favor with regards to support. For example, Joe Biden was unclear, no response on it. Kamala Harris, unclear, no response on it. Kristen Gillibrand, Amy Klobuchar, Beto O'Rourke, unclear, no response on it.
There was no response on, what was the question?
On whether they not support building more nuclear power plants.
Okay. Yeah.
So Sanders is just no. Let's phase that shit out. Elizabeth Warren, no. So and a bunch of them were just no new plants at this time. Whereas Pete Buttigieg, Bloomberg, a bunch of these guys, so Castro, whatever. There's only really Andrew Yang and a couple other dudes that are Cory Booker that are pro expanding nuclear power. But it goes to show that it's definitely lost favor with the current political class, with the current political talking points don't include nuclear. Now keep in mind that Biden's been in there from probably like the inception of nuclear. So he's probably been there from the jump. So I'm sure at one point he was pro-nuclear when it was like the hot button thing. He's been in freaking office for 78 years or whatever it is. But I want to talk about this interesting point that was raised in some of the articles that I read, which focused on this specific thing, which said people speak of nuclear being unequitable because it disproportionately targets indigenous communities. Right? This was an issue that was raised, that people that sometimes are at the downstream end of nuclear are indigenous communities which suffer from some of the negative aspects of nuclear. Or maybe that wasn't even it specifically, but it's just kind of saying in a general sense that there's an unequitable impact of these energies. I mean, we can talk about the issues of that statement of what an unequitable impact is, but I just want to focus on this point that it's essentially stating that indigenous communities suffer more from nuclear power than other people. Okay, well, I mean, are we all accessing the same amount of electricity? I think so. We think we're all accessing the same amount of power, right? When you flick on the switch, there's no really discrimination for who's flicking the switch on. If you turn on the electricity, power comes on. So one thing that they fail to recognize is that lithium batteries are generally sourced from impoverished African countries like in the Congo, where children are used for labors. And then comparing that to nuclear and say, oh, nuclear is really the bad guy. It's leading to impoverished communities and this and that. Meanwhile, neglecting the fact that their poster child solar, and I know there's a lot of push against this, sourcing lithium from more, from sources that don't degrade humanity. Let's put it for what it is, that don't use fucking children to mine that shit. Like this, let's face the facts. Like, get off your fucking high horse. All right. Like, comparing batteries to nuclear also neglects the lifespan of the technologies. Nuclear is proven to function for 30 to 40 years with refurbishments allowing for even longer operation. So 30 to 40 years plus. Batteries have a limit in terms of the cycles of operation. And at the utility scale, so at the big scale, lithium batteries reach a lifetime end of 7 to 10 years. 7 to 10 years. And if they're not operated properly, which is to say that there's no thermal management, so they're not operating in the proper thermal environment, that is cut down to about 4.9 years. So you're dealing with comparing something that lasts you 30 to 40 to potentially 50 years to something that lasts you 5 years. Now, just going back to the nuclear thing and the unequitable side of things, I also just want to point out that during the mining again, when you're saying that things are unequitable to Indigenous people, I want to just point out how the mining process works in Canada, because I have experience in this, and it's not to say that this is done all over the world, but in Canada specifically, when it comes to new mines being built, there is always 100% of the time, that's 100% of the time, consultation done with stakeholders who are Indigenous communities that are going to be impacted in the area. This is true 100% of the time. Whether or not it was done historically, maybe not. But as of right now, and for the past at least, let's say, 20 years, every single mine built in Canada has had Indigenous consultation. Not only that, but they have promises to have a certain amount of Indigenous involvement in the work. So that means that there's benefits that the communities are receiving. So when we have these statements that there's an unequitable impact that nuclear energy has to Indigenous populations, maybe it's specific to certain parts of the world. But I just want to point out that in other parts of the world, such as Canada, this is not necessarily true, because there is lots of consultation that is done upfront. I know that's not what you see in the media. I know that's not what you see in the news, because that's not what's hot and sexy and gets the clicks. But I can guarantee you, and you can look this up online, every single mine built in Canada has had Indigenous consultation for the past, I want to say 20 years or so, if not 10, let's say at least 10 to 15 years. And there is a specific emphasis put in order to make sure that those communities, if those mines are in the area where indigenous people do occupy, that they are either parts of the employee base, so they are employed by the mine, so they're receiving economic benefits and from the actual work that's done. But not only that, but they just receive lump sums of money. You just get checks, get cash, you just get signed cash. So all that to say that when we're talking about unequitable impact, I mean, let's again, we got to look at the specific case at hand, because there's quite a bit of extensive consultation where people's indigenous people's thoughts, ideas, rights are considered.
Yeah, and let me add to this. So there was a time period where there was no consultation that happened with stakeholders as Indigenous people, and mines were built. And I have personally worked on projects in my company where we look at what is the state of these mines after they've been abandoned. These are older mines dating probably before 10 years or before 10 years ago, right? Before this consultation process happened. And especially in Canada's north, this, I would say, does have an impact that because these are companies that, came in, they did the mining. For some crazy reason, they were able to abandon their waste and give it to the government to deal with. And it's, when you're dealing with mine waste, there's a lot of it. But what happened is, because there was an economic, situation going around a mine, this also spurred sometimes communities of indigenous people living near the mines. And so there's some places that these mines are basically being managed by the government right now, and they have impacted the quality of water and the land around it, and they have to be monitored all the time. And in this way, I would say, we're not living in a perfect world, so there, without negating those circumstances, they must, this has to be considered. But I think you said, this is a broad statement. You got to look at it individually. The other part is, when it comes to nuclear power, there's often this idea, hey, I like it, but not in my backyard. So whose backyard is it going to go into? And is it even reasonable to have that perception? And I would say it is reasonable. I'm somebody who goes, I like the idea of nuclear power, okay? But I can understand someone's fear of, what if something goes wrong? What if someone attacks it? What if, I don't want to be wiped off the face of this earth because I had the unfortunate circumstances of having a nuclear power plant in my backyard. And I think to that, we have to look at the track record of nuclear power plants, and of them, not of just the ones that did fail, and the circumstances around why they failed in different parts of the world. And we also need to tip our hat towards the idea of these smaller module nuclear plants and what they can do for us. Because one of the things you said was, when you flip on the light, for anybody in Canada, don't we all have access to us? And it's true, yes, but to some extent, there's this smaller fraction of the world that live in such remote places that they are so far from the grid that running transmission lines to them is not feasible, not economically feasible. So we need to develop. They often need to develop independent power stations that just work for them to gain their power. And I think modular nuclear is a very promising, thank you, technology, especially because of its ability to work in cold climates. Whereas some of having a solar bank and combined with power storage, or a wind turbine combined with energy storage, are promising but limiting in what they can do. And the small scale of the modular power plant makes it very appealing too, because you have to transport or build these things in remote areas, and the cost goes up when you have to build or bring materials from a distance to build these things. So
yeah, it's a whole nother ball game right there when it comes to providing power for the North. Then that's just a whole nother. We could go another 2-hour podcast on power demands of the North, because that's almost like a totally different ball game, because now we're dealing with diesel, which is the primary thing that's used over there, right? And how SMR, small modular reactors, could be the alternative. They're not there yet, but I have heard estimates that by 2030 or so, Canada is definitely one of the countries among some of the other ones too, but they're really pushing towards developing the nuclear modular reactors for small scale. And I want to just touch on a point that you brought up, though, that when it comes to the historical construction of mines, 100%, back in the day, there was no laws and regulations when it came to mining, governing mine waste. It was the Wild West. People set up mines, the Yukon Gold Rush. Everybody was there trying to just set up a little mine, get some gold, whatever. And, even after the fact, there was much more mining that was done that was, just private companies kind of doing what they wanted without very much consultation to the local communities and the government. So I 100% acknowledge that. And what I'm saying is that currently in 2020, so that essentially all that can be true, But it can also be true that currently in 2020, that is not how things are done. So that's what I'm saying, is that that was historically done, and that's historically true, and that was awful. I 100% agree with that, because that's fucking bullshit. You didn't sign up for all this crap to come into your lake, but now all of a sudden these mines come and they're dumping this crap into your lake. That sucks. What I'm saying right now, though, is that in 2020, if you were to compare the two, if you were to compare how a uranium mine, which is the source of nuclear power, for example, and uranium is primarily mined in Saskatchewan, in Canada specifically. So we're looking at the prairies, right? Kind of like northern Saskatchewan. It gets really cold up there. But those are where we're getting our uranium from. Whereas somebody else might be getting their solar lithium or their battery for their lithium for their battery storage from the Congo. So that's the equivalency that I'm making, is that in 2020, the roles are not the same as they were in 1920. And right now, getting our uranium from Saskatchewan, from the good old prairie boys over there, I'd rather get that than getting a bunch of kids, even though maybe it's getting them some economic opportunity, but fucking up their health. Yeah. To me, I have much more of a moral satisfaction knowing that the source of that energy came from Saskatchewan, from proper workers that are going to get paid what they're supposed to be getting paid, that the indigenous communities in the local area were consulted, all that was done properly, and as opposed to, like, I don't know, getting batteries. I mean, there's no perfect solution. So I'm not trying to be on a high horse over here myself either. There's no perfect solutions either way, but just saying that point. 2020, things are a bit different than how they were.
For sure. And I would agree. I think the more we can have the mining and manufacturing happen in Canada, the better, because we can for sure regulate and verify the standard of the work environment, of making sure that people's human rights are protected. And I think that's a good thing. And it honestly will show us if we can pull this off economically without relying on places where those things like human rights or wages are given up in order to become manufacturing powerhouses that then give us the technology that we use in our own countries. That seems backwards to me and almost unfair. So I would say it's, I'll just reiterate, I just think it's better if we can try to prove that we can do this in Canada with local mines, local work.
Yeah, instead of us, what we're doing was we're outsourcing our pollution. We're taking the pollution that would have resulted here and the potential tough decisions that we made here, and we're outsourcing that to other countries for them to have to make, and we're essentially kicking the can down the road, as they say. And it's kind of gross because it's just out of sight, out of mind type of mentality. I don't see it, so I don't have to think about it. But you know what? That's why we're here, to make you uncomfortable. So wake up. The truth hurts, bitch. It's all good though. We love you still. But anyways, that's a bulk of the articles that I wanted to cover. Now we can jump into some of your clips that you had ready there, Elliot.
Well, here's what I'm thinking. Let's wrap this bad boy up, and you're going to get a nice two-parter where we're going to jump right back into this discussion of energy storage. But let's close the book right here.
Okay.
And we'll pick right back up on the topic of energy storage in a general sense in our next episode. And
can you give some detail on some of the things that you have ready for everybody for next episode, so people can get a little wet?
Oh yeah, definitely. All right, so this is what we're going to look at. Energy storage, batteries, Tesla. This is what you've heard about. Lithium ion, it's a great emerging battery technology. You're able to put it into electric cars. Electric cars are going to take off. But this is just one of many technologies coming out. So in a general sense, I'm going to go over all of the technologies. We're going to look at what is being promoted in the mainstream media, what some unique independent individuals are working on that seem promising. And we're going to talk about in a more general sense, like what does it mean to for players like Elon Musk or Bill Gates. And then I think what we should do after we get into energy storage is perhaps focus in on hydrogen. That's what I think might be a nice segue after that. But that's what's on the agenda.
I like it. We'll go from broad to specific. All right, that's it for today. Thank you all for joining us. Talked a lot about energy storage, renewables, battery storage technologies, nuclear. And yeah, hopefully you guys got some value from it. If you like this, please go to Apple Podcasts or wherever you get your podcast from. Give us a thumbs up. Give us a positive review. It definitely helps us out. Really appreciate it. Check out our website, www.firstprinciplespodcast.com. firstprinciplespodcast.com, where you can check out all of our latest episode. It's a nice little directory, a little catalog where you can pick up on all the interesting stuff that we've talked about. Anything else you want to touch on, Elliot, before we sign off?
Only that the website is continuing to be built. So check in on a regular basis. You'll see more features and on it as we advance.
Yes, sir. More bells and whistles to come. All right. I hope you guys are enjoying your 2021 and signing off, and we'll catch you next time. Peace.
Peace.